So here we have 2.3, solving radical equations graphically. Radical equations can be solved by isolating the radical on one side of the equation and then applying the appropriate power to both sides of the equation to eliminate the radical. So what that means is we get the root by itself and then we square both sides to get rid of the root. Each solution does have to be checked, and you can either verify or check against the restrictions. So I'm going to explain all that here as we go. So the first one we have, solve the following radical equation. So here we have root x minus 4 minus 3 equals 0. Step 1, we need to get the root by itself. So I'm going to add the 3 to the other side so that the root is alone. So root x minus 4 equals positive 3. Then I can square both sides to get rid of the root. So I'm going to square the root of x minus 4, and I'm going to square the 3. When I square the square root, they're inverse operations, so they even each other out, which just leaves me with x minus 4 on this side, and equals 9, right? 3 squared is 9. So pretty easy to finish this off. We just add the 4 over, so x equals 13. Okay, so that is my answer. Okay, so then we're going to look at restrictions. So the restriction, what are we not allowed to have under a root? Negative, right. So I have to say that the part under the root, so the x minus 4, has to be greater than or equal to 0. The part under the root has to be positive in order for this to work. So all we do then is add the 4 over. So this says that the x has to be greater than or equal to 4. So that would be my restriction. Again, in order for the situation to work, it's going to have to be greater than or equal to 4. Let's go back to our answer. Does it meet the restriction?
Yes.
Yeah. Yes, it does. Okay, good.
Indeed.
Now finally, we could check this as well. And we check by plugging your 13 back into your original equation. So we'll get the square root of 13 minus 4, subtract 3 equals 0. The square root of 13 minus 4 is 9. And the square root of 9 is 3. So 3 minus 3 equals 0. Yes, it does. So again, double check. But that x equals 13 does work. Alright, so let's try our next example here. This one has two separate x's. One is under the root, one is not. So this one's going to take us a little bit more work. Step 1 is still get the radical by itself. So I'm going to add the x over and subtract the 2 to the other side of the equation. So we get root of 2x subtract 1 equals x minus 2. Again, when I move the x and the 2 over.
Okay, I was wondering where you got like the...
So now that the root is by itself, we will square both sides. Now on this side, it's going to be real nice. The square and the square root will cancel, so we just get 2x minus 1. But on the other side, when you square x minus 2, be careful you guys. When you square x minus 2, that means x minus 2 times x minus 2. So we actually have to go through and FOIL it. So x times x is x squared. X times minus 2 is minus 2x. Another minus 2x. And then a minus 2 times a minus 2 is a plus 4. So again, just like normal, we FOIL out because you're multiplying a binomial times a binomial. So once we move everything to the other side, we get x squared minus 6x plus 5. Because the 4 and the 1 gives us 5. So now we've got a quadratic to work with, but we have to factor this quadratic. So we think what two numbers add to get to negative 6 and multiply to get to positive 5. And right away we should see that x minus 1 and x minus 5 would give us negative 6 and multiply to get positive 5. Once it's factored, we set each factor equal to 0. So x minus 1 equals 0, or x minus 5 equals 0. So one of my answers is that x equals 5. The other answer is that x equals 1. So two options here for answers. X equals 5. So then you should be doing your restrictions and your check. But on this one, when we try our second check, so the second check is with the value of 1. So 2 times 1 subtract 1 minus 1 plus 2 equals 0. So again, I'm putting 1 in for the places that I had an x. When we do this, we get 2 times 1 minus 1 is going to be 1. So we have square root of 1, subtract 1, plus 2. So 1 minus 1 plus 2 actually equals 2. So 2 does not equal 0 in this case. So it shows that our check has not worked. So the x equals 1 does not check. And remember that when something does not check, we call that extraneous. So this is an extraneous root because it did not check. So remember from Pre-Calc 20 that the term roots and solutions mean the same thing. We're always talking about either where the graphs intersect with each other or the x-axis. So I want to show you this, you guys. This is a graph of the situation we just did, the example we just solved. So we had a line on one side. The line was x minus 2. Remember our equation was 2x minus 1 equals x minus 2. That was our equation. So what I did here is I graphed the line of x minus 2, and I graphed the equation of root 2x minus 1. And what we do is we're looking for where they're equal. So on a graph, where the line is equal to the radical is right here. And there's only one spot that that line and that radical are equal to each other and where they hit. And that was at an x value of 5. So that was the answer we got to work. 5 worked. Now I also want to show you, if you type in the whole equation into decimals, it would then look like this. So then we're talking about where the graph hits 0, right? Because this is equal to 0, equals root 2x minus 1 minus x plus 2. That was our original equation. So here we're looking for where the graph hits 0. Well, it hit 0 here at 5, just like we found. So when you're graphing these, there's two options. Either you graph each side separately and find where they cross, or you graph the one side all together and find where it hits 0.